Okay, we are moving to the chapter 2, the vector algebra of the subject multivariable calculus BE 20303. So we have the content, the scala, and okay, what's the difference between scala and vector? Okay, unit vector, the arithmetic of the vector algebra, including the addition, subtraction, position, and distance vector. The vector multiplication, which includes you have the dot product and the cross product, and then component of a vector. Okay, scala and vector. Okay, triple product. So first of all, okay, scala and vector. Okay, as you know, as you learn in the physics in secondary school, scala is a quantity that has magnitude. I have here has only magnitude, like okay, you have what temperature. Okay, you have only the magnitude. Vector is a quantity that has both magnitude and directions. So mean quantity here you can divide it into scala and vector. Okay, scala quantity, for example, you have the power, current, distance, electric positions. Where is it? Okay, electric potentials. Vector, for example, you have the force. Okay, displacement, mean the displacement, you have the velocity, acceleration, then you have the magnetic field, electric field, intensity. Okay, and scala is represented simply by a letter such as A, B. So if vector here in mathematics will denotes the quantity A here in the bowl. Okay, some books they may have a this symbol. Okay. I cannot write. Okay, some they may some sort like A here or arrow. Okay, some they may have this caret on top of A or the arrow on top of A, or normally mathematics we just use a bold A here. I think you should have any question or not, okay, regarding the scala and vector here, the difference between scala and vector.
So far, no, not yet, Doctor.
Yeah, thank you very much. Then proceed to the vector algebra, addition, subtraction, multiplication in any given coordinate system. So in the first chapter you have seen you have the coordinate system in 2D and 3D. So same thing, the vector algebra here we're including up to 3 dimensions. Okay, and then let's say this is a vector A. The vector A. Vector, as we know, we have directions and magnitude. Okay, this is a magnitude A here, and then if one unit of this magnitude A, let's say we denote here, this is a unit vector A. That's why vector A, if vector A, this is bold, this is quantity, that's why it's a normal italic. Normally it's italic. For mathematical symbol is normally we italic it. For vector it is bold. So vector consists of the magnitude, which is you see the italic A here, and then this is a directions. You see this is a unit vector, mean it is one unit only, the magnitude is one unit, and the direction, you see the direction, the is pointed by the arrow here. So mean vector A is A unit. Mean the magnitude is A in the directions of unit vector A. So you see so vector A have the magnitude, has a magnitude about A and in the direction of unit vector A. Or we can, if we want to find unit or given a vector A, given you want to find the unit vector A. So from here the unit vector A will be vector A divided by its magnitude. Okay, sometimes its magnitude will use this symbol stand for magnitude. So is it okay? Mean if given a vector A, you want to find the unit vector, mean from here, unit vector will be vector A divided by the magnitude of the unit vector, by the magnitude of vector A. So here, so this is the magnitude of unit vector A is always one unit. That's why it's called unit vector. Okay, this is unit vector A. For any unit vector, the magnitude is always one unit. Okay, any question? If no, I will just proceed.
So far no, Doctor.
Okay, thank you. So now we look at in 3 dimensions. You have we always in the anti-clockwise directions. X-axis, Y-axis, Z-axis. For X-axis we have a until here this is a AX unit. So is let's say this is AX unit, and then you draw a line parallel with your y-axis, and then let's say in the y-axis we have about ay, mean the quantity is about ay. So let's say at this point is ay, then you draw a line parallel with your x-axis, and then so at this point, so this point will be the coordinate, its coordinate is actually ax, ay. Okay, and you see when we connect here, this is what in polar coordinate, this will be the r here. Okay, and then you raise up r. Let's say in z-axis we have the magnitude is about az unit. So from the r here, you raise up about a positive az unit, up to here, and then this will be your vector a, where at the coordinate ax, ay, az. Okay, and then we can write the vector a, cos ax, ay, az, their unit vector mean in the x, y, z axis. Their unit vector is actually I, j, k. So we'll write vector a as a axi plus ayj plus azk. This is in in the rectangular coordinate system. Compare just now, if just this one is any direction. So vector A magnitude multiply its unit vector. This is in any direction. But if in the in the rectangular coordinate system, if they're in so vector A, their x-axis is about ax unit, y is about ay unit, z is about az unit, and we know x, y, z, their unit vector, we denote it as I, j, k. So vector A is actually can be written as axi plus ayj plus azk. Sometime we also can represent in using this less than symbol. Then we can skip the notation of ijk. We'll write this as ax, comma, ay, comma, az. So it's either you have axi plus ayj plus azk. So you notice the vector of here we bold it. Ijk is bold, a is bold. If we don't want to write the unit vector ijk, we can have another notation, which is the symbol less than. So you open the less than symbol, but don't use a round. Round stand for coordinate, stand for a point that ax, x is about ax unit, y is about ay unit, z is about az. If you want another way to represent the vector, you may from the round bracket, you change to this is a less than symbol, this is a greater than symbol, or you may use this notation axi plus ayj plus azk. So now you have vector A. if you want to find the magnitude of vector A, is actually you will take the square root of ax. Okay, you can see, okay, let's say in 2D only, then the extension you can do it to 3 dimension. Okay, the x-axis, and then this is a y-axis. Okay, for x-axis, okay, you have the ax unit, y we have the ay unit. So like your polar coordinate. So this point is actually a ax ay. Okay, round. This is coordinate. This point is actually ax. X is about ax unit, y is about ay unit. Okay, the magnitude. Okay, the magnitude of, if let's say 2D. Yeah. Okay, if your vector is, okay, now I just show 2D. Then okay, so vector. uh, Because if we write, you cannot write both. That's why sometimes some book they will use, okay, arrow stand for this is vector A. Is a, okay, and this is notation stand for axi ayj. Okay, I want to get the magnitude of this vector A in 2 dimension. Then okay, the magnitude is actually, okay, your vector is here. Okay, if let's say x is moved, okay, in positive x-axis, y is a positive y-axis. Okay, the vector is, okay, you move x ax unit, y ay unit, so the last point is here. So the resultant vector, this is the vector A. Okay, vector A is axi plus ayj. The magnitude is actually, okay, the hypotenuse here, or is actually equivalent to your, okay, r in polar coordinate. Okay, where using Pythagoras theorem, you will have, okay, a mean the magnitude here squared is actually ax squared plus ay squared. So magnitude A, that's why you have the square root ax squared plus ay squared. This is for 2D. So if we extend to 3D, that's why we get the square root of magnitude of vector A will be, oh, I think the slide typo. Okay, the square root of ax squared plus ay squared plus az squared. If you are printed the slide, you may just, okay, make the correction. So this is the magnitude of a vector. You have a big, okay, big square root. Take its, okay, take each component. Component I, you square it, add up. Component Y, component J, you square it. Component K, Z, you square it. Okay, and to get the unit vector A, mean a unit, okay, vector A is here. Okay, we want only a unit. A unit will be the vector A divided by its magnitude. That's why the unit vector A is axi plus ayj plus azk divided by square root ax squared plus ay squared plus az squared. So far, okay, we introduced, okay, you a vector A in the, okay, in Cartesian coordinate, in 3 dimension Cartesian coordinate, and then how to find its magnitude and how to find unit vector. Okay, is it okay?
So far okay, Doctor.
Okay, thank you, Hadi. Okay, the rest, okay, please respond also if you, okay, cannot understand. So for the first example, a vector A is given as A equal to 2i plus 3j. Sketch A and determine its magnitude and unit vector. This is 2 dimension. So you just, okay, draw your xy axis, and then x, okay, is 2 unit, okay, positive 2 unit, y, okay, in the y axis, positive 3 unit. Okay, I think I just, if you want to draw in 2D only, also can. And this is a x, this is a y. Okay, x, let's say 2, y is 3 here. So mean you move x 2 unit, okay, go up y 3 unit, the resultant is here. This is your vector A. Coordinate is 2, 3. Okay, or here. Okay, determine its magnitude and unit vector. So magnitude of a vector A, okay, as you said, you have the square root. Takes a component I, you square it, so 2 squared. Component J, you squared it, so 3 squared. So 4 plus 9, so 13. So this is the magnitude of vector A. Okay, and find unit vector A. Okay, let's say I put it A, unit vector A will be your vector A, because if we use word, then we can bold it, but if normal writing, to differentiate whether vector, I can put the arrow here. So unit vector is a vector A divided by magnitude of a vector A. So you may have 2i plus 3j. Here you can put like this, divide by 13. Or you want to break each component at, let's say, 2i 13 plus 3j 13. So either one. You want to combine it or you want to break it. Okay. So example 1 should have no problem, right?
Doctor, sorry to interrupt.
Yes.
One of my friend Tanesh, he trying to join this group, but he can't join. He message doctor at Telegram also.
Danish, I think last tutorial also not join, right?
Yeah, he facing this problem. He can't join.
Why? Clash.
I don't know, doctor.
Can't join or what? If Clash, I have to change the sections. If not, last tutorial we did one quiz. Then each of the quiz will be 0 and the attendance must 80%.
Doctor,
Yes.
can the answer for the example just now,
Mm-mm.
uh, we also can separate it, doctor.
Yes. No, you can break it.
Oh,
Because your denominator is one term, you can break it. So 2 over 2 over 3i plus 3 over 3j, or you want to leave like this also can.
oh, okay. Thank you, doctor.
Okay, welcome. Okay, this is 3D vector in 3 dimension. So how to read it? Okay, you see x is 2 unit. So b, vector b, will be 2i. Because you see how they sketch the vector in 3 dimension. Okay, x2. Then from x, you draw horizontal line parallel with your y-axis. So how long you want to draw? You just draw a line parallel to your y-axis. Okay, let's say y is 5 unit. 5 is here. From 5, you draw a line parallel with your x-axis. Okay, so these two lines, the intersection of these two lines is here. This point is actually 2, 5. So you have 2i plus 5j. Okay, and then from here, so this is actually the like your r in polar coordinate. Okay, your r. Then from here 2 point we have z is about positive 4 units. So this is plus 4. Okay. Okay, and then from here you drag. Okay. So how long are you draw this one? Is it are you draw like this? This is wrong. Okay. So how long you want to drag your positive 4? Is it same same height with here? This is wrong. Correct one. This one is actually this case. This dotted line is actually parallel with the r. These two, they are parallel. Well, I put 3. They are parallel like this one. Okay. So this is how you sketch vector in 3 dimension. because afraid some question they may ask you to sketch the vector in 3 dimensions. So the way, let's say 2i plus 5j plus 4k, x is 2, so you have 2 unit here. Okay, draw a horizontal line parallel with your y-axis. Y, let's say 5 unit, you can put it here. Y, drag it parallel to your x-axis. Their intersection is here. Then you drag it from, this is origin to this intersection point. This is actually the R in the polar coordinate. Okay, and then if the z is positive 4, then you drag up 4. If negative 4, let's say you drag up 4, negative 4. If let's say negative 3, and then so negative 3 mean the, some will drag, mean the same height, which is wrong. Let's say this is z, let's say this is negative 4, and then from negative 4, they will drag parallel with here, some sort like here. This these two parallel. They cannot like this one. So this is a vector B, 2i plus 5j plus 4k. Find its magnitude. Then against your vector B, magnitude, you put this symbol. Magnitude of a vector, square root. Take each component, you square it. So 2 squared. Component j, 5. So you square it. Component k, you square it. Okay, then you just solve it. So 2 squared is 4. 5 squared is 25. 4 squared is 16. So you have, this is 20, 45. Okay, if you want to simplify, 9 times 5. So you have 9 times 5, 3 5. Okay, either leave 3 5 or you want 45. Okay, this is a magnitude of vector B. Unit vector B. Unit vector B. So unit vector B will be the vector B divided by magnitude vector B. Okay, vector B, you have 2i plus 5j plus 4k. So divided by magnitude, either you use cert 45 or 3 cert 5. Let's say you use cert 45. You may leave it this form, or you want to break 2 or you want to break 2 over cert 45i plus 5j I here, cert 45 plus 4 cert 45k. So either one. So still in a very front topic, magnitude of a vector and unit vector. So is it okay?
Doctor,
Okay.
can I ask a question, Doctor?
Yes.
Doctor, for just now, for
Yes.
the B on above,
Mm.
for set 40, 45,
Uh-uh.
we also can simplify it, Doctor?
Yes.
Or also we can leave it on set 45.
Yes.
Oh, okay. Thank you, Doctor.
Or you may seize your calculator. Whether the calculator simplify. See, you put the cert 2 squared plus 5 squared plus 4 squared. See, they give calculator straight away give you the simplified form 3 cert 5. If you solve manually, let's say you may leave this one or you want this one, but calculator straight away give you the simplest form 3 cert 5. So it's either you divide by 3 cert 5 or you divide it by cert 45. And then either in this form or you break ijk component there.
Thank you, Doctor.
Yeah, okay, thank you. So in the slide already have the answer. You can just recheck it. Okay, now the vector addition and subtraction. So if let's say this is a vector A, the blue color, vector B, the red color, they are in different direction. You want to do A plus B, yeah? So you draw the vector A in the, okay, wait, A is here, sorry. A, the blue, okay, blue arrow plus B. So, okay, at the end of the vector A, you add up with vector B. So, okay, that's why the resultant A, this direction, add up with B. That's why, okay, the destination, okay, this is a from starting to the, okay, ending. So this is a vector C. Vector C is a plus B. Okay, if subtraction A minus B, A here, positive B, add up B is actually the go down. So if negative B, same magnitude but opposite direction. So A minus B. That's why the resultant, okay, you see the blue color is up, another direction compared to A plus B here. And then if you want to do the, okay, this is, okay, in the diagram form, mean the graphic form. If you want to do, okay, just okay, arithmetic, okay, A plus B or A minus B is just very easy. Okay, let's say A is represented by AXI plus AYJ plus AZK, and vector B is represented by BXI plus BYJ plus BZK. If you want to do A plus B, then you just, okay, add up component by component. Mean I add up with the component I. So that's why I have AX plus BXI. Okay, for component J will be AY plus BY. Okay, and then component K will be AZ plus BZK. Yeah. So similarly for subtraction, okay, just addition change to subtractions. I think you are already familiar, okay, with the vector in the secondary school. So I skip to the example. Oh, okay, example later on. Okay, one is a position and distance vector. Okay, position vector is actually, if you have a coordinate, let's say coordinate P here, okay, P is actually, okay, the magnitude for X is about XP unit, for Y axis is YP unit, okay, Z axis is ZP unit. Okay, so this is a coordinate P, XP, YP, ZP. Position vector is actually a vector, okay, mean if you have any point P, and then if we say position vector is actually, it start with origin, mean O to P, O to P. Okay, so the position vector of point P is actually OP, mean O stand for origin, O to P is actually XPI plus YPJ plus ZPK. Okay, if distance vector is actually, you have an, okay, from any point P to Q, P to Q. Okay, OP, this is a position vector. OQ, this is a position vector. This is a position vector of P. This is position vector of Q. So you have OP, OQ. Now we want to find vector P to Q. Vector P to Q is called distance vector. Okay, any vector start from origin is what we call position vector. Okay, to find vector P to Q, okay, it's very easy. You just take the last, okay, ending coordinate, mean XQ minus XP. This is, okay, for the component I. For component J, YQ minus YP. Component K, ZQ minus ZP. Okay, so means, okay, vector PQ, take, okay, coordinate Q, deduct coordinate P. And then, okay, X axis, actually you have the, okay, unit vector I, the Y axis unit vector J, okay, Z axis a unit vector K. And the distance for a, okay, distance for PQ. Okay, this is distance for PQ. Same thing, you have to find a distance of vector. You have the square root, take each component. Component I, you have XQ minus XP, and then you square it. Component J is YP minus YQ minus YP, you square it. Component K, you have ZQ minus ZP, and then you square it. So this is, okay, distance vector and distance, okay, of a distance vector, mean distance of PQ. Okay, and then we proceed to the example maybe. Yeah. The third example, you have 2 points P1 and P2 are respectively located at -3, -2, -5. Okay, see how they do it. X is -3. Okay, front is positive. Okay, positive. So negative. So mean okay. You have here -1, -2, -3 here. Okay, from -3 is actually we draw horizontal line parallel with y-axis. Okay, y is -2. Okay, y-axis here. Okay, right hand side is positive, so left hand side is negative. So go to, let's say, how they draw -1. Okay, this -1, -2 here, -2. Okay, so from this -2, you draw a line parallel with the x-axis. So this line and this line intercept. Okay, and this point is actually -3, -2. Okay, and then z is -5 unit. Okay, z is -5. So it's actually from here, mean the r is here. So z, okay, from this from this intersection, you draw it, drag it. So z -5, let's say -5 is here, and then why you not drag this way? Why you drag this line? Because this line is actually should be parallel with the the r here. So this is a P1 where coordinate is -3, -2, -5. Okay, and so this is P1. P2 is +2. +2 is here. So draw line, a line, horizontal line parallel with the y-axis. And then y is -4. I say -4 here. You draw a line parallel with your x-axis. So this point is actually 2, -4. And then the z is 3, +3. Okay, from here, actually, when you drag like this one, okay, here and this line parallel. Okay, about 3 unit. From here, 3 unit, drag it parallel with the r. So this is P2, where the coordinate is 2, -4, +3. And then find the position vector of the point. So mean you want to find the position vector, mean you want to find O P1, O P2 of the point and determine the distance between them. So mean the distance between P1 and P2. Okay, distance between, so mean magnitude between P1 to P2. So the position vector is very easy. P1 is negative, coordinate is -3, -2, -5. Then the vector, the position vector OP1 will be -3i, -2j, -5k. And then the position vector OP2, from the coordinate 2, -4, 3. So it will be 2i minus 4j plus 3k. Okay, you want to know the distance between them. This is a magnitude of P1, P2. Then you need to find the distance vector P1 to P2. Okay, the vector P1 to P2. Okay, you take OP2. Mean the vector OP2 in the ending point. Mean vector OP2 deduct vector OP1. So 2i minus -3i will become or 2 minus -3. This is component I. Add up. Component j is -4 minus -2. This component j. Okay, component k, you have 3 minus negative 5. This component k. So 2 minus negative 3, so this will be 5i. Okay, negative 4 minus negative 2, so mean negative 4 add up with 2, so minus 2j. 3 minus negative 5, so add up with 8k. So this is the distance vector P1 to P2. You want the distance P1, P2. So the distance P1 to P2, you have the magnitude. Take the each component you square it, so 5 squared plus you have negative 2 squared plus 8 squared. So 25 plus 4 plus 64. Okay, so you got 25 plus 4 plus 64. 29 plus 8. Let me see. So 93. Okay, so the distance between them will be the third 93. 93, 92, sorry. 93, correct. So the answer is third 93. Position vector negative 3i minus 2j minus 5k, and the OP2 is 2i minus 4j plus 3k. Okay, they didn't say distance vector P1, P2, but they want the distance between them. Before you can find distance between them, you need this vector. Okay, so any questions here? You can see.
So far, no, doctor.
Yeah, so 93. So done. Okay, if now we move to the vector multiplications. Okay, we have the simple product. If the vector is multiplied by a where's my go on? I think where is my pen? Okay, just the vector multiplication. The simple product. Let's say vector A is multiplied by a scalar scalar k. So vector times scalar, the result still vector. So for example, let's say your A is maybe 2i plus 5j plus 8k. Let's say you got 7 times of vector A is multiplied by 7 times. The result still vector. If multiplied by 7, so each component will be multiplied by 7. So you have 14i plus 35j 56k. So this is a vector multiplied by a scalar. The result still vector. And then if let's say 7a, mean the magnitude is 7 times and their direction is still the same. Because it's let's say A is this direction, vector A. So if 7a means 2 times, 3 times, 4 times, 5, 6, 7. So still in the same direction. 1, 2, 3, 4, 5, 6, 7. 7. Okay. So this will be 7. So that's why if we multiply by a scalar, it's only the magnitude multiplied by the scalar. The direction still the same. Then we have the dot product. Vector dot a vector, the result is scalar. okay, and the dot product A dot B is actually equal to magnitude A multiply magnitude B multiply with cos theta. Okay, mean if let's say you have A here, this is B, the theta is here. So the dot product, the result is scalar, and where the theta is the angle between vector A and vector B. Cross product, okay, result is actually, okay, the result is a vector, and so A cross B is actually magnitude A times magnitude B sin theta. Okay, and the direction, okay, if we can use never mind, later on we show you using the figure there. Okay, if you use your finger, the thumb and the finger, okay, and later on move to here. Yeah, like here. So the cross product, so you can use, okay, your, okay, using your right hand, right hand. Then you have here one, this one showing your finger, okay, finger. This is a fingerprint, this is a thumbprint. No, sorry. No, this is actually A cross B is actually your thumbprint, and then A and B is, okay, are the other two, okay, fingerprint. The direction is actually, mean the A cross B you will get, okay, using the right hand you will get this one is always pointing up, and is a unit vector normal to the plane containing A and B. So this is a cross product. Cross product, okay, the result is a vector. Okay, then we move back this one. Here. A cross B is equal to A B sin theta, and the result is a vector. Then the simple product, as we have shown just now, if B is K times A, then you take a scalar K multiply with each component. Okay, the dot product, you have, okay, red color is A, B. So theta is, okay, between vector A and vector B. Okay, and the projection of vector B along the vector A is actually B cos theta. Yeah, because using the cos theta, you have this one, okay, this adjacent divided by vector B. Okay, let's say this x, right? The position x. Okay, this is a vector B. That's why the x is actually B cos theta. Means here. Mean the projection of vector B along the vector A is actually B cos theta. And then definition of dot product, A dot B is AB cos theta. Okay. And then the dot product, why the result is scalar? Because, okay, you have I dot I, J dot J, K dot K, the result is 1. I dot J, J dot K, K dot I, the result is 1. Okay, A dot A, you have the A squared. So if you want to, okay, do dot product of, okay, two vector. Okay, done. Here, for example, A is, okay, AXI plus AYJ plus AZK. B is BXI plus BYJ plus BZK. Then, okay, sin I, okay, when you take AXI, dot with BXI, because I dot I is 1, that's why you have AX multiply BX. And then when you take, let's say, AXI, okay, when we do, okay, if you want to AXI multiply with BYJ, because I dot J 0. Okay. Similarly, yeah. Later on, if you take AXI, if you take AXI dot with VZK, because I dot K 0. That's why you only consider AXI dot BXI, where the result is AX BX. Similarly, if you take a J dot with component I will be 0. So only J dot J is 0. That's why you have AY dot, okay, multiply with BY. So component K, if you dot with I or component J, the result is 0. That's why it's only AZ dot BZ. Okay, K dot K is 1, so the result is AZ, okay, multiply BZ. Okay, that's why, okay, for the dot product, the result is scalar. The result is scalar, okay, and it's very easy. You have a AX, okay, as a, okay, conclusion. For dot product, you just take component I, okay, multiply with I, so AX plus BX, I dot I is 1. Okay, I dot with other component will get 0. Then J dot J is 1, so you have AY plus BY. J dot with other component will get 0. So is K dot with K only, okay, you get positive 1. So AZ with BZ, other component will be 0. So this is a result for your dot product. Okay. So is it okay? Then we look at one example. Find the dot product of vector A equal to 1, 3, negative 2, and vector B equal to negative 2, 4, negative 1. Then calculate the smallest angle theta between the vector. Okay. Since we know the dot product A dot B is actually AB cos theta. So after you get the dot product, and then you can find the magnitude vector A, magnitude vector B, then you take the cos theta, it will be A dot B divide magnitude A, magnitude B. Then theta will be at cos A dot B, okay, divided with magnitude vector A, magnitude vector B. Okay, and then so the dot product for A and B. So you can put out magnitude vector A dot vector B. Okay, you can put out, okay, I can put another notation for vector. This is 1i, 3j, negative 2k dot with negative 2i, 4j, negative k. So the dot product, just the result is from component I dot I, because I dot I is 1, other component will be 0. So you have 1 multiply negative 2 plus, take component j dot with j, because j dot j is 1, other component will be 0. So 3 times 4. Okay, component k dot k is 1, other component will be 0. So you have negative 2 times negative 1. So you have negative 2, okay, plus 12 plus 2. Answer is 12. Okay, and then calculate the smallest angle theta between the vector. So you have the cos theta, because you have the A dot B is actually AB cos theta. So A dot B, if you want to put here, magnitude vector A, magnitude vector B. Hence, okay, you need to find magnitude of a vector A and magnitude of a vector B. Okay, so magnitude of a vector A, you have the square root, take, okay, 1 squared plus 3 squared plus negative 2 squared. So plus 3 squared plus negative 2 squared. So you have 1 plus 9 plus 4. So you have cert 14. And then your magnitude vector B. So take each component, you square it. So negative 2 squared plus 4 squared plus negative 1 squared. So 4 squared 16, negative 1 squared is 1. So you have cert 21. So the cos theta will be A dot B. Okay, A dot B, which is 12. Magnitude vector A is cert 14. Okay, this is cert 21. So the theta will be arc cos 12 divided cert 14 times cert 21. Okay, where's the calculator just now? Yeah, hold on. Hanging. Okay, so your calculator. Okay, make sure in radian mode. Shift cos. You have 12 divide cert 14 times cert 21. Or you can combine in one cert also can. So you get, okay, is 0.7956 radian. Okay, we can check. Okay, that be 12, correct? Okay, this one using okay 45.6. Okay, if you want in degree, and the answer. So okay, if you in degree, then the answer here, this is degree 45.6. Okay, if I put okay in radian, again, so it's 0.7956. So radian, okay, if degree, make sure you have the symbol of degree here. Okay, so far, any questions here?
So far, no yet, Doctor.
Okay, thank you very much. Okay. Then if no, I think will be the cross product. The cross product. Okay, A cross B is A magnitude A times magnitude B sin theta. Okay, and the result is a vector. Theta is angle between A and B, and okay, the vector n is a unit vector normal to the plane containing A and B. In here. So if red color is A, B here, A cross B, you use your right hand finger and the middle finger, and then your result is actually your thumb here, the thumb. Okay, thumbprint. And then you notice the vertical point here. This vertical, this is a B sin theta. If horizontal, this is X, this is actually B cos theta. Okay, like your polar coordinate, right? If you call this X, so the Y R sin theta, X is R cos theta. Now the R is denoted by vector B. Okay, and for cross product, you notice is actually magnitude A times B sin theta is actually here. This vertical. That's why the cross product is actually the magnitude is equivalent to the area of the parallelogram. Here. So A cross B. Okay, the cross product the magnitude of A cross B actually represent the area of the parallelogram from the vector A and B. Cos the area of the parallelogram is actually you have the red color, which is a vector A, multiply with the vertical distance, which is a B sin theta. So vector A, the magnitude of vector A multiply B sin theta. B sin theta is actually this vertical line. You get this area of the parallelogram formed by the vector A and B. So mean the application of cross product, you can find the area of the parallelogram. If the dot product, you can find the theta between A and B there. And then the cross product, the result is a vector. So how we do the cross product? Okay, for cross product, I cross I, J cross J, K cross K is 0. And then I cross J, because IJK positive. And then JK, because you follow the sequence, IJ, you get K, JK, you got positive I, KI, IJK, and then JK, you get I, and then IJK, JKI, and then KI, K, because put it I, J, K, I cross J, you get K. Okay, J cross K, you get positive I. K cross I, you get positive J. Mean you put in like circle. I cross J, I cross J, K. J cross K, I. K cross I, J. And then A cross A is 0. So let's A is AXI plus AYJ plus AZK. B is BXI plus BYJ plus BZK. A cross B. Okay, to do the cross product, the result is a vector. That's why you have an IJK. So how to get the component? Each component. To get the I, component I is actually J cross K. So mean, to get component I, you close this one. So J cross K, that's why. And then you have a determinant of matrix 2 by 2. Then what you need to do, you take the main diagonal, deduct with the other diagonal. J cross K. So AY multiply BZ minus AZ multiply BY. So J cross K is positive I. And then you see to get the positive J is K cross I. So direction is opposite. That's why we will do normally why we to get K positive J. Positive J is actually K cross I. To get J, so you close J here. But if we use the same direction here, main diagonal deduct with another diagonal, so if you put this direction is actually I cross K, we have negative J. That's why for component J, if you take AX multiply, you have to negative outside, AX multiply BZ, so minus AZ multiply BX. So this is negative. So negative we get so this one is negative. AX multiply BZ minus AZ multiply BX. So it's negative because I cross K is negative J. Unless you take K cross I. K cross I mean you take if you take K cross I, mean it's AZ BX. We will take this direction minus another direction. AZ BX minus AX BZ. So you see, when you negative, so that's why it's positive AZ BX minus AX BZ. So for component J, it's up to you. If you maintain the same orientation, okay, takes a I cross K is negative J, unless you take K cross I. So component J, be careful. If you take I cross K is negative J. So is it okay for component J?
So far okay, Doctor.
Okay, so the slide here, you make correction, this is negative. Because if we maintain the same direction, taking the main diagonal in this direction, deduct the other direction. So component J is actually I cross K is negative J. Okay, after that, to get K, I cross J. Okay, I cross K. So you have AX BY minus AY BX here. Then we look at one example. Okay, determine A cross B if A is 2x. Okay, this one is, I think, this notation is a EMT notation. It takes the ijk, mean the unit vector in x direction as a like this notation. Then B is negative cap x, negative cap y, negative cap z. This is this notation is from the EMT notation, so it's actually equal to 2i plus 3j plus 4k. B is negative I, negative j, negative k. So if A cross B, the orientation is very important. Make sure you put A first. A cross B. Okay, then you put I, j, k. A is the first row. Because A cross B not equal B cross A. So 2i plus 3j plus 4k. So negative 1i, negative j, negative k. The result is vector. To get component I, you close this one. You close it, okay? You so you have 3 times negative 1. 3 times negative 1 minus 4 times negative 1. Okay, this is component I. So minus 3 plus 4, positive I. 4 minus 3. Okay, if you can just do it quickly, you can skip the writing here. So 3 times negative 1, negative 3. This is minus negative 4, so plus 4. So 4 minus 3 is positive I. Hey, component J, if you use the same notation, can I change color? Okay, component J, you close it. If you use I cross K is negative. I cross K, the result is negative. So you have 2 times negative 1, 2 times negative 1 minus 4 times negative 1 component J. So you have here minus. So minus 2, add up with 4. 4 minus 2 is 2. So minus 2J. Right? Yeah? Or you take this one. Negative 4 plus 2, negative 2J. Okay, and then component K. Okay, component K, I close it. Positive. So you take like this. 2 times -1 minus 3 times -1. This is component k. So -3 times -1 is positive 3 minus 2. So it's plus k. Okay, you see, actually, you can actually use a calculator, I think. Okay, especially the cross product. Okay, the vector mode. You can define the vector A. Dimension is 3. So input is 2, 3, 4. Okay, and then you clear it. You go to options. Okay, 1. Define vector B. Dimension is 3. -1, -1, -1. -1, -1, -1. Okay, great. Now I want A cross B. So option. Vector A is number 3. Cross, just use a multiplication button. Then option, you make it. Find the way using your calculator. So 1, the cross product, your result 1, -2, 1. If you want to do dot product, see, I clear it. Option 3, and then the option, the dot product here, number 2. Option number 4. The dot product is -9. Okay, you can check. Okay, A dot B. Okay, component I with I. So 2 times -1, J with J. 3 times -1, K with K. So 4 times -1. -2, -3, -4, -9. Okay, the dot product. Okay, as I said, A cross B not equal to B cross A. You can quickly get the answer from your calculator. So option 4. This is B cross A. Option 3. Okay, B cross A actually opposite direction. -1, +2, -1. Okay, so B cross A, you get -I, +2j, -k. Okay, this is from calculator. So you can, for your test, this topic, chapter 1, chapter 2 is only covered in test. So you have, you can show, you have to show the manual, and then, because you normally careless mistake, so you can use the calculator here to double check whether you calculate correctly. So, but provided you also input correctly lah. If you input wrongly, then you cannot check whether both are correct or not. So any question or not? Okay, how to use, maybe how to calculate manually, or how to use your calculator to get your cross product, dot product, and actually you still have, I think, dot product can find the angle, unit vector. But I think the most useful is a cross product lah, because it normally careless mistake. Dot product because simple arithmetic operationally. So any question?
All good, doctor.
Okay, thank you. Okay, good. We I think the next example. Correct. So -1, 1, -2k. Okay, this is Scala triple product. Okay, A dot B cross C is equal to B dot C cross A equal to C dot K, C dot A cross B. Okay, if you got A dot B cross C, you do the B cross C first, and then the result of B cross C later on you do the dot product. Then you can if you given ABC, then you can prove that these three are actually equal. A dot B cross C is equal to B dot C cross A equal to C dot A cross B. Okay, this is a scalar triple product. Then A cross B cross C not equal to A cross B cross C. Okay, as we have shown just now, if B cross C first, and then this one is said A cross B cross C not equal to, if you cross A cross B first and then cross C, cross the vector. If the normal quantity is same, I think not important. Okay, this one not, that one not very important. Now we look at example 6. Given the A is I minus 3j plus 2k, B is j plus k, and C equal to negative 2i plus 3k. Find A cross B cross C and compare it with A cross B cross C. Okay, so you just do the cross product for the first one, and then compare with A cross B cross C. Okay, so if you want to quickly get the answer, you can input the calculator and you can get the answer quickly. So but in the test you have to do manual, then you have to do A cross B. Here, A cross B, 1 negative let me check. If this is negative 3, I negative 3j plus 2k. Okay, component I negative 3 minus 2. I think got mistake. Okay, unless the question, let me check. I want to erase. So this is A is I minus j plus 2k. For component I, the question here, negative 1 minus 2 negative 3i. So the question, please edit it. This is I minus j plus 2k. I minus j plus 2k. So component I minus 1 minus 2 minus 3i. Okay, and then component j, erase this one. Okay, component j, if it takes like this, 1 minus 2, so remember, component j have negative, so you have actually negative. 1 times 1 is 1 minus 2, so you have negative j. Okay, later on component k, 1, so this is this product is 0, so positive k. So this is A cross B. Later on cross with C. So negative 3i minus j plus k cross with C. C is negative 2i, we don't have j, so it's 0j plus 3k. So same thing for component I. Okay, when you close it, negative 1 times 3, you have negative I because the other product is 0. Okay, later on component J, you close it. So if we use this direction, yep, negative outside. So negative 3 times 3, negative 9. Okay, and then this direction is minus negative 2, so it's plus 2. Negative 9 plus 2, negative 7, outside negative, so positive 7J. Okay, lastly, component K. Okay, have here. Negative 3 times 0 is negative, and then minus, minus is positive 2, so negative 2K. So lastly, A cross B cross C have 2I. What's that? Okay, A cross B cross C, the result is negative 3I plus 7J minus 2K. Okay, this, oh, the result, this one, A cross B cross C is 2I plus 4J minus 2K. You may check it here. Let's say you do B cross C first. B cross C, I, J, K. B is 1, 0, 0, 1, 1. C is negative 2, 0. This is 3. So B cross C, component I, okay, component I, you close it. So you have here only 1 times 3, so it's 3I. Okay. Erase this one. Erase this, this, this. Okay, later on component J. Okay, yeah, negative outside. 0 times 3, 0. And then minus negative 2 times 1, which is plus 2. Outside is negative. So I have negative 2J. Okay, lastly, component K. Okay. Component K, you close. So minus minus K with negative 2. So you have plus 2K. Okay, later on, you take A cross B cross C. So A cross with B cross C. Yeah, I, J, K. A, okay, A is here. 1I minus J plus 2K. So B cross C is 3, negative 2, positive 2. Okay, component I, negative 2 plus 2. Plus 4. Okay, I want to erase this one. Okay, component J, you close this one. So it's actually negative 2. This is minus with negative 4. So 4 minus 2, you have 2I. Okay, here, negative 2, the minus with the other product, which is negative 4. So become positive 4 minus 2, 2I. Okay, and component J, okay, 6 minus 2, 4J. If I use this direction, 3 times 2 minus 1 times 2 is positive J. Or you use the same notation. If you use this direction, 1 times 2 is 2 minus 3 times 2 is 6. So 2 minus 6, negative 4, outside negative, so positive 4j. Okay. Lastly, the component k. You have k 1 times negative 2. So negative 2 minus k 3 times negative 1, which is negative 3. So this is k 2i plus 4j. So 3 minus 2 is positive, positive k. 2i 4j minus 2k. Let me see. Negative 2 plus 3. This should be okay. This one is positive k. Okay, we can check. Okay, we can put quickly ABC into your calculator to double check. Okay. Okay, I can options. Okay, edit vector because I want to change the component of vector A now to 1, negative 1, okay, 2k. So 1, negative 1, 2. Clear. Options. Okay, edit. This now vector B, change to 0, 1, 1, 0, 1, 1. Okay, then options. Okay, okay, I haven't defined vector C. So number 1, I define vector C is number 3. Dimension is 3. So negative 2i, 0j, 3k. Okay, we check. Okay, we check back here. Let's say options 3, vector A cross vector B. We check back, okay, using calculator. So negative 3i, negative j plus k. This is A cross B. Okay, and A cross B, actually, this is stored in vector answer. Later on, I want to cross with vector C. Yeah? So you see, I just, you can clear. And then the options. Yeah, actually, I no need to clear. Never mind. If I clear, actually, just now I straight away take the vector answer cross with vector C. But since I clear, okay, I call back vector answer 1 cross. The option vector C is number 5. So I get negative 3i, 7j, negative 2k. So this part is correct. Okay, going to check. Okay, if B cross C, so clear it. So option, you take B, number 4, cross. Option C is number 5. Vector B cross vector C. 3, 3i, negative 2j, 2k. Okay, so this vector, and then, I want A cross vector answer. Okay, vector answer at the back. So I clear first. So I call number 3. B cross C is stored in vector answer. So option, find back the vector answer is 1. So 2i plus 4j plus k. So there's a careless mistake in the slide. So please edit it. 2i plus 4j plus k. And the question A here also change it to I minus j plus 2k. Okay, so any questions here?
So far good, Doctor.
Okay,
So far good, doctor.
okay, thank you. So you can see that A cross B cross C not equal to A cross B cross C. Yeah? So here you see this answer and this answer are not the same. One more. done. We finish the content of the lectures.